Welcome to the first video for Unit 2. Today what we're going to do is talk about the history of the development of the atomic theory, and we're going to talk about the different scientists that contributed to our understanding of atoms. And so 150 years ago, 200 years ago, what we know about atoms today, they knew nothing about. And so it's actually really interesting to think about because after this unit, you're going to be more knowledgeable than those who were living 200 years ago. So it's really interesting. So let's talk about, we're going to talk about four individuals today. And you don't need to remember dates or anything. All you need to memorize is how did they contribute to the development of our understanding of the atom. And so the first person we're going to talk about is John Dalton. And John Dalton came up with four statements based off of experimental data that describes the atom. And so let's go ahead and look at those four statements. Now the first statement says all matter is made up of extremely small, solid, indivisible particles called atoms. He also said that atoms of the same element are identical. He said different atoms will look different. He said atoms are neither created nor destroyed. They can only be rearranged in chemical reactions. And then he also said that compounds consist of atoms of elements combined in simple whole number ratios. And so those are the four things he said. Now if you take a look to the right of those statements, you'll see that two of them are true and two of them are not exactly true. They're close, but they're not exactly true. So let's go ahead and go through that. So number one, all matter is made up of extremely small, solid, indivisible particles called atoms. And so I'm going to underline the word indivisible because we're going to learn that atoms actually are divisible. And so that's actually something that's not correct in his statement. All right. And the next thing we're going to talk about is number two. Atoms of the same element are identical. Different atoms look different. And what's not true about that is the word identical. And so we're going to learn later on this unit that two atoms of the same element can actually have differences. So now what I'll say is the other two statements are true, so it's pretty good. So atoms are neither created nor destroyed, but rather they're just rearranged in chemical reactions, and that's true. And so what happens is atoms are bonded together, and then in a chemical reaction, those bonds will break. The atoms will rearrange themselves. Maybe they will then bond with a new element, or they'll bond with the same element in a different way. But the point is that bonds are broken, atoms are rearranged, and then they form new bonds. And so that actually is true. And then the next one, compounds consist of atoms of elements combined in simple whole number ratios. And so give you an example of that. We can think about what water is H2O. And notice how there's two hydrogens to every one oxygen. And so those are simple whole number ratios. It's a 2-to-1 ratio. And so that is true as well. And so even though he got half of it right and half of it wrong, that's still pretty good considering that no one knew anything really about atoms back then. So that's actually pretty good. So let's go ahead and move on to the next fellow here. So we have J.J. Thompson, Joseph John Thompson. And so what he discovered that atoms could be subdivided. And so that's why John Dalton's indivisible particles is actually not correct. Because he discovered that they could be divided. And so particularly, he discovered the electron. And so he discovered the electron using cathode ray tubes. And so I'm going to go ahead and circle this word right here because that is the key contribution that J.J. Thompson contributed to the atoms, that he discovered that electrons existed. And so the reason why he was able to discover that is because he discovered that atoms have negatively charged particles. And we're going to learn later that those negatively charged particles are electrons. Now he developed an understanding of the atom with a model called the plum pudding model. And so I'm going to go put the word plum pudding. So he developed the plum pudding model. And for those of you who don't know plum pudding, I'm going to throw some images of plum pudding on the screen right now. And if you take a look at those plum pudding models, you'll see that what plum pudding is. You'll see that it's like bread with a bunch of, I'm assuming raisins or something are in there. And so what he said is that the atom is actually this positive sphere, and within that sphere, he said there's a bunch of negatively charged particles that are uniformly spread throughout that he called electrons. And so he said it's this positive sphere, and throughout the sphere are these negatively charged particles. Another name for that model is the chocolate cookie model, the chocolate chip cookie model. And so if you think about a chocolate chip cookie, you have the chocolate chips kind of spread throughout the cookie. And so that is the model that J.J. Thompson came up with. The next person that's on our list here is Ernest Rutherford. And so Ernest Rutherford, he actually discovered that there is a nucleus within the atom. And so he performed the gold foil experiment. So I'm going to underline gold foil because that's the experiment that he used to discover this. And essentially what he did is he took a very thin piece of gold foil, very, very thin. He hammered it very thin to where it was as few atoms thick as possible. And he shot alpha particles at the foil. And so we never talk about alpha particles. So in this class, we haven't learned about alpha particles. That's okay. But the hypothesis was that if the plum pudding model was correct, all of the alpha particles would go through the gold foil. And what he discovered is that most of them actually did go through the gold foil. However, take a look at this picture here. Notice how most of them did go right through. But there was a small amount of them that either ricocheted off to the side or they bounced backwards completely. And so even though most of them went through, some of them did not. And what he was able to conclude is that the atom is mostly empty space. So atoms are mostly empty space, and that there is a nucleus in the center of the atom. And so he is the one who discovered the nucleus. And so what his model became is there's this nucleus, and around the nucleus we have these electrons that are just kind of around the nucleus, and they're just kind of, spread out around there. And so he was the one that discovered the nucleus, and so that's very important to know. And also very important that he's the one who said that atoms are mostly empty space. So just a quick thought. What are you made of? Well, you're made of atoms. And what are atoms? Well, atoms are mostly empty space. So if atoms are mostly empty space and you are made of atoms, that means that you are mostly empty space. However, atoms are matter, and because you are made of atoms which are matter, that means you matter. So just a punny joke there. All right, last one, Niels Bohr. So before we talk about Niels Bohr, I want to do a quick recap, very quick. We have Dalton right here. Dalton is the one who came up with those 4 statements, 2 of which are incorrect. The 2 that are incorrect are atoms can actually be divided, and 2 atoms of the same element do not necessarily have to be identical. And we'll talk about that second one later on this unit. Then we have J.J. Thompson. J.J. Thompson, he discovered the electron. Then we have Rutherford. He discovered the nucleus. And now we are at Niels Bohr. Niels Bohr discovered that electrons orbit the nucleus in very specific orbitals. And so this is kind of how we know the atom today. And so what this model is called, it's called the Bohr model. And we have a nucleus. And around the nucleus, let's go ahead and get some nice fancy rings here. So there we go. We have these specific energy levels around the nucleus. And the electrons will actually be on these specific rings. So what I'm going to ask you though, just a side note, how many electrons go on the first energy level? Well, this is something that you did learn in middle school at some point. But the first energy level should have 2 electrons. The second energy level, how many should go on the second energy level? Well, we have a total of 8 electrons on the second energy level. And notice how I'm pairing up the electrons, and so we'll talk about that later. And then the third energy level, well, in middle school they told you there's 8 electrons on that as well. But we're going to learn later there's actually 18. But for now we'll say there's 8. So the first energy level has 2, the second energy level has 8, and we're going to, for now, say the third energy level has 8. But later we'll learn that's different. But essentially what Bohr discovered is that the electrons are on specific energy levels, all right? And so let's go ahead and underline the part. So electrons have fixed energy and energy levels. And so the electrons exist in specific orbitals. And so I'm going to go ahead and go back real quick, and we're going to look at our everything that we've gone over so far. So John Dalton came up with the 4 statements, 2 are false. J.J. Thompson discovered the electron. Ernest Rutherford, with his gold foil experiment, discovered that the atom has a nucleus. He said that the electrons are just randomly around the nucleus, and then Niels Bohr came along and said, well, actually the electrons live in specific energy levels. So they're either in the first one or the second one, but they're not in between. And so then we have this last group of scientists here, where they developed the quantum cloud model. We will talk about that a little bit in a future unit. For now, we're not going to really talk about those guys. So you just need to know those 4 scientists. You need to know how they contributed to our understanding of the atom. And that's it, just four scientists. You don't need to memorize the dates or anything. So, but what I will point out is, notice when the electron was discovered. It was discovered in 1897. That's a little bit more than 100 years ago. So if you go 150 years ago, if you were to travel back in time, you would be more knowledgeable than the people that lived then. So just an interesting thought. You guys have a great day.